Welcome to Coding Adventures. Today we are continuing the lessons about functions and discuss about closures. Let's get started! Alright, so I'm here on my desktop and I open a web page and I navigate it to Wikipedia and I'm looking what Wikipedia says about closures. And says that in programming languages, a closure, also lexical closure or function closure, is a technique for implementing lexical scope name binding in a language with first-class functions, and the definition continues. It's such a very, very academic definition indeed. So, and the rest of the page, it's also full of information and details from various programming languages. It's a good read indeed, but perhaps for a code newbie, we should basically take baby steps toward understanding closures. So let's close for now the Wikipedia page and basically understand through some simple examples here in the code editor what a closure is. And we're gonna start with defining a function first. Let's define a function calculate. And this function, takes two arguments, two parameters, a and b. And we did these kind of functions many times in the past. Perhaps let's write it really quickly again in the way we wrote it in the past, returning the sum of the two numbers. And outside of the function, we can basically invoke the function saying calculate 2 and 3, and we can print the result, right? So nothing out of extraordinary until now, out of ordinary. So let's run it. We see indeed number 5, exactly like we did so many times until now. But now notice what I'm gonna do with this function. Instead of actually returning this expression, what I'm gonna do, I'm going inside the function and pay close attention here. I'm inside the function and I'm defining another function. A function inside the function. So we have a smaller function, or it appears smaller, inside the outer function, and we name this one sum, right? So perhaps this one should return instead a plus b, just like this, and instead here we should invoke the smaller or the inner function. So we should return the result that is returned by this one. Do you think this code will run? Will work? Let's test it. All right. The function still displays number 5. So let's take a moment and understand what's happening here. So the first function is pretty clear, the outer function. It's called calculate and takes some parameters. And inside we have another function that doesn't take any parameter apparently, but somehow this inner function has access to the parameters of the outer function. And then when we are invoking, basically these smaller functions will run, will basically read the a and b parameters and will return the sum. Therefore, the calculate function should return the actual sum. And to be a little bit clear, we can take this one in a separate variable. Perhaps the variable should name it, we usually name them sum, but since we already have a function named sum inside, we cannot do it. We can name it result, and we can return result, something like that, right? So as you can see inside here, we basically execute this function while we are still inside the calculate function, and then we are returning the result, which is basically a number. So at this point, result is a number. We can put here a comment, return result as a number, and let's run it. Indeed, it's number 5 here. So we already see here a closure, what is called a closure. So a closure is basically a function, like for instance, let's say this function, together with its lexical context around it. So this particular function has already access to a and b parameters, although these are not in its own in its own lexical scope. They are not received like parameters here, but they are seen above. So what JavaScript is doing in this case is basically building a little bit of a bubble, to name like that, and captures all the other kind of information that it's around this function. So this function will have access to those. But perhaps more impressive, and actually we'll have even a better demonstration of this one just in a second. So what about in this one, if we'll just, let's notice these two lines. What about instead of executing the sum function here, what if we return the actual function? We return the function, right? We saw in the previous lessons that functions behaves like data, so you can pass them around, as we can take them in variables, you can pass them as arguments, but we never return the function until now. So let's see what's happening if we try to return a function from within a function, right? So probably something will not work, so let's run it. And we see some text displayed here. And what is displayed, actually println will receive the sum, which is now a function, and will display the body of the function. So because the calculate will return a function in this case, if we want to see the result of that function, we have to execute it. So here we should run sum like this. And if we run it, we should see indeed number 5. So this is even a little bit more impressive, and here is the power of closure where it comes very handy. In many situations this is used, like this kind of pattern to return functions from within functions, and people that are familiar with a new technique of or not saying new, but with a different techniques of development named functional programming, they find this kind of coding very comfortable. All right, but let's take a little bit, let's take a few more examples to better understand closures. For now, let me save this one. So this is basically calculate or closures one. Let me save this one, and I'm gonna paste it on the chat. The program, I put the link to the program on the chat. And the program is on the chat there. And I'm gonna, yes, it's on the chat. I'm gonna create a new program, brand new program, and let's create another one. I'm thinking to create one called printer, like you know, some sort of a utility function that basically prints some messages. But of course, this one will be a special printer because we're gonna use closures here. And this printer will take one argument here. Perhaps I should name this one borders. The idea is that we want to implement some sort of printing mechanism that the user may specify some borders or not, and the text that will be displayed will be enclosed in borders that are specified here. All right, so inside the printer, we're gonna create now another function named print. And this is the print that actually is printing the message, right? But what we're gonna do, and for the moment we're gonna just use our println instruction, the regular text message printing instruction. And what we're gonna do, we're gonna first print the borders that the user will provide. Then we're gonna print the actual message. So let's put a println with s, and let's print borders one more time after this. And eventually we can also print an empty line just to have a little bit of a separation between different prints. So we have an inner function here, right? That prints a message, and obviously we can see that this message is basically delimited by some borders that the user will provide. And now we're gonna return the function. This time we are returning the function. We are not executing the function inside here, but we are returning it. So if you look closely, it's like we have a small factory here. The printer function, the outer function, is like a factory that produces smaller functions. The print is a smaller function produced by this factory, right? So in a sense, we'll have to call our factory function and ask it to produce a print function. And once we get the print function, we can invoke it with the rest of the parameters. So let's see how we can invoke it basically here. The first one, we can say let, or let's use const this time because the return is a function that is not expected to be overwritten. So const makes totally sense. and is actually recommended to use as const as much as possible if you know, for instance, that variables are not getting overwritten. So let's take in a variable. Perhaps this variable we can name it print. It's the same as the name inside, but you know, these are totally different. We can name this variable however we prefer, and we're gonna invoke the printer function, and let's put some borders, because obviously the printer function expects to pass as an argument some borders, and we're gonna put a small string like that, right? So after the first line, we are expected in the print variable to have a small function, and we need to invoke it. But when we're gonna invoke it, obviously, if we look here carefully, we need to basically specify some message. So let's put a message here and see what's happening. All right, it says JavaScript. Let's invoke it a couple of times. Let's say, what other programming languages do you like? Python, probably. What about Basic? Does anybody remember Basic? It's an ancient programming language enjoyed by kids in the 80s. Anyway, this is just an example. So let's see it. Now, if we run it, we see the true one displayed. And it, in a sense, it's like the printer, this factory function fabricated this print instruction or print function that we can now use it to print these messages. But this print, notice, is printing not only basically this text, but also printing the borders. Basically, it's accessing the context and is printing the borders, exactly like we see here in the implementation, right? And now we can create another factory. Perhaps we should have the second one, let's name it type, like this, type. And we should have another printer, and there's characters, maybe stars here. And let's say this time type JavaScript. If we'll do this, we should basically see JavaScript displayed in an enclosed with stars, because right now we are calling we're using another factory here, right? So how can we, this example is basically implemented with print, with closures. It warns us about redefinition of print because we already have print, but don't worry about that, it's perfectly fine. This is a perfect example of closures. Now, just for the purpose of understanding how can we build this one without closures, or how could we build this one if we don't have closures, let's implement here another function here, perhaps function myPrint. We just call it myPrint. We'll have to basically pass both arguments, both the string that we want to print and the borders, because right now we'll have just one function, and inside we can do the same thing as print is doing. The invocation, though, it's a little bit different. So let's see how we invoke myPrint. So myPrint, we invoke it, myPrint having to basically, if we want to print, let's say JavaScript and Python, we can say myPrint, but it's not enough. We also have to pass, because see, the function expects to have the borders on each call, so we can have it pass like that, right? So if we run it, of course, we should see basically the same kind of result. Let's put here different delimiters. And in most cases, actually, you don't have to build closures. It's perfectly fine just to build the functions like here, as basically simple regular functions. Closures are a little bit more expensive because also from the point of view of the language when it parses the code in order to identify properly the closure, also at runtime, from the memory point of view, from performance point of view. Closures are a little bit more expensive, so you should use them basically only when you need them. And we're gonna do a few more examples to just better understand when you need closure and when you don't need closure. But this is very, very powerful features of JavaScript for functions to basically be able to somehow live beyond the point when their outer function that returned them ended. And actually we didn't discuss about this one, but if you look closely to this one, right, about printer. So for instance, let's take back the first example here. We say printer and we pass this string of characters, this, and then we get the result, right? The function ended. Line number 2, the function ended. In many programming languages, this would have ended the function. But notice, here obviously JavaScript is doing something differently, because the inner function still lives there in the memory. It's not terminated, because we can invoke it here. And the function not only that lives in memory, but has access to its surrounding context, lexical context, has access to the borders variable that basically was passed via the outer function, right? So this is a very, very interesting feature of the language. It's also very powerful. It's characteristic to JavaScript, but also to other modern languages nowadays. And perhaps we should also take this one a little bit on the paper, just to illustrate them a little bit. So I'm gonna grab my notebook here, and let's try to write this one on the paper, right? So what we implemented here, we implemented a function named printer, and you know that takes some arguments. Can take any arguments. We just, in our case, we just say it takes a border. Perhaps can take color, can take a font size if we want to build a graphical printer, can take all sorts of arguments. But the main idea is that inside lives another function that can have whatever name, and you know, PR, and that takes its own arguments and, you know, lives happily inside here. And at one point the outer function is returning the inner function from inside. So what's happening is, like, we have this big box here, and inside this big box there is a smaller box here and we are returning it outside, right? So we are returning it outside, and outside we can take it in a variable like we did here. Let print equal, of course we call the outer function if we want to basically get access to the inner one, printer, and we pass whatever arguments we want. And this call here is basically, we're gonna get a function, of course, and this function, we get access to this inner function that it's inside, but not only to the function itself, but also to the surrounding context. Like the function, the closure captured basically like in a bubble. This is a bubble or slash closure, or enclosure, as some people like to say, captures also all the syntactic, lexical, all the variables living in this lexical boundaries. So for instance, capture border here, and if we define other variables here, perhaps whatever, let A, let B, these would have been captured as well. So it's a very interesting concept. So it's like a function within function, and the inner function has access to all the other outer context, and we can do this kind of interesting implementations that we never did them before, like we saw here with the printer, and we saw with the calculate before. All these are possible basically via this concept of closures. And let's complicate a little bit this example here. So the function, we don't have to actually have it like a named function inside, unless we are using it from within the outer function. In many cases, you can just return this one like an anonymous function, just like that. And we saw about anonymous functions, right? So this is how basically a closure can look. If we look at it, it's an outer function that has just a return and is returning a function. So it's basically the same. The only difference is that we made the function, the inner function, anonymous. As you can see, is no longer named print, but that doesn't matter. In the moment when we take the return of the printer, we can take it in whatever variable and we can name it however we want. We can name it print, we can name it type, and still will work fine. exactly like we see here. All right, so this is example number 2, and it's a little bit dry perhaps. So we're gonna try to create 1 or 2 more examples to clarify better closures. Closure 2. The example is still on the chat there. So yeah, let's do this one that we mentioned. Maybe we're still building on the printer concept, but let's do a graphical printer, shall we? So basically, instead of using println as a support, inside we'll use text, which will basically print in graphical mode, and you know, just will give us one more opportunity to basically explore closures, right? So let's have a function printer that this time maybe maybe this printer should take as arguments a size for a text that we want to display, centered, if we want the text to be centered on the screen or not, perhaps even a color. Yeah, I'm using CLR just not to override color, which is also there. Okay, so let's attempt to write it from the very first time using an anonymous function. So what we want this printer to be? We want to be a factory of functions. So we want to return a function that will actually print, right? And will print a text, a certain coordinates. So since we are not passing the text and the coordinates to the outer function, we will pass them to the inner function. So we're gonna return a function, an anonymous function we said, that takes as an arguments perhaps a text that we want to display, like s, perhaps the string at x and y coordinates, right? And that's it. We are returning the anonymous function. Of course, we are not not finished here, but let's see how we're gonna use it, and then we're gonna complete the implementation. To use it, we're gonna say yes. So let's use it like this. Perhaps we can have a function title that basically represent a big text. So we'll ask our factory to produce us a title function of certain, we'll specify the size, something very big. The title should be centered, yes, indeed. And the color, perhaps title should be red to attract attention, right? And perhaps we should reuse the printer factory and define another function, paragraph that is basically, imagine an word processing document. You have the titles and you have the paragraphs, right? Paragraphs, we are also asking the printer factory to return it. And here is basically, this is a smaller one, it's 12, it's not centered, and is black, basically, right? So we're gonna say printer, this one, right? So to be a little bit more clear, just for beginners, it's perfectly fine to name this one printer, but maybe you should, since we mentioned so many times the word factory, maybe you should say here create print function. We'll just name it like that. Nothing changed, but just choosing a different naming convention maybe makes a little bit the code more easy to read for somebody that wants to read it. So we'll have title, create print function. So we are expecting that now this function should return a function, because it says in the name there, we cannot return a number. That would be so funny, right? So we are returning these functions and we have them, and the way we plan to use them, of course, we're gonna see in a second. We plan to basically say title, and perhaps now we have to look here what these arguments are. So basically, perhaps we should specify a text like JavaScript, right? We are writing a document about JavaScript. We are printing a newspaper about JavaScript. And perhaps we should have it some coordinates here, right? That's how we're gonna use it once we have, because title is now a function. If we want to be even more specific, we can name this one with a verb inside, such as print title, something like that. And then this one will look print title. We can do that. Yeah, we can do that just because we use this convention to have some verbs here, and this one should be print paragraph, right? But still, nothing changes. These are just the names of our variables. Alright, so now let's see how we implement this one in order to do what we want to do. Obviously, the text we're gonna display it using with the text function, and these are basically the string that we want to display at x and y coordinate. But let's make use also of the other kind of information that we have access from within this closure, and kind of, you know, make the text size bigger, eventually choose an alignment, choose a color, something like that, right? So how can we do about centered? Well, center, let's say it's a Boolean variable, right? Like we are passing here true and false. We can say if centered, and you know, we can use the text align function. We use it in one of the previous lesson. So if it's center, we should just align it perfectly on the center. Let's say else text align, and we can use left bottom. These are predefined constants. It's not the nicest looking code here. We can compact it even more, but it's fine for now, right? So we use this one. We use the, oh, we didn't use the size. Let's use the size. So the size is very simple. We just say text size with the size that is specified. And again, I want to highlight here size and basically centered. They are not coming as parameters to the inner function, but because of the closure in working mechanism, the function can access them from its environment, basically from its outer lexical context, right? So it's perfectly fine to use them here. We use center. Eventually you can use also the color. Yeah, let's use the color as well. Let's implement the color as well. We know that text looks best when we don't have a stroke around them, but instead we have a fill. We use the fill to fill the inner part of the text. And we used with that one, and then we use text, right? So the text looks kind of complete. Let's say this one closures 3 or 2. I think 3. We'll save it and let's give it a try. All right, we have JavaScript. Let's try to say again print paragraph just below that. We'll have a print paragraph. And now we have a paragraph. I love to code in JavaScript programming language. It is so fun. Anyway, something that we want to print. This one, we should not center it. Oh, actually, already the paragraph contains that information. We just put the coordinates, right? So it's like we are putting the coordinates something like 10 here and 150, something like that. And if we run it, all right, we can see also the text. And it's exactly like we implemented this like perhaps in HTML or in word processing. We separated the style from the actual content. So all the style associated with the title is basically contained here. The title has the size 60, it's red, it's centered, all this information. And then the function itself just receives as argument just the text that we want to print and some coordinates, right? And we can create more functions. Perhaps we can, if we want to print a subtitle, we can go here, and we don't have to change the factory function right now, right? We can say print subtitle, and how the subtitle should look alike. Similar to title, I guess, but perhaps a little bit smaller, right? So perhaps 40 here should be also centered. And let's say give it a different color, Indian red, something a little bit close to red, but perhaps not red, right? So let's use this function, print subtitle, and here is basically, what can we say about JavaScript? Any idea on the chat? Let's say a coding story for now. And it's also centered and perhaps at 150, and let's move this one a little bit down to 50. Let's see it. All right. It's kind of, you know, it's funny looking kind of word processing. Perfect. Perhaps you're doing a much better job here. But the concept about closures, I hope that it's basically illustrated here. Again, we have this function here that has access to a surrounding environment basically, and also this function lives after the create print function finishes. And JavaScript keeps tracks all of this, and it's very good that deallocating memory when it's not needed. So anyway, as you can see, these are basically some very pretty simple and classical examples of closures. You know, we can continue to have more of these ones. They are perhaps a little bit abstract now at the beginning, but I'm gonna show you one other use of closures that I think we're gonna find it a little bit nicer or friendlier for beginning. Closures are also very good at creating modules. What's happening, perhaps you may ask, if we place more than one inner function instead of that bigger function? So let's do that one. Let's create a function here, mathutils. It's a regular function, and I use capital case M here just to indicate that it's one of these factory functions. But inside, let's create a few functions. So perhaps this one, mathutil, should be a factory producing mathematical functions. So what kind of functions can live inside? Let's create a few simple ones. You know, we don't want to create now functions for solving various mathematical equations, although it's possible, but we're gonna create simple ones. So one should be add, right? And can live inside here, and this one returns a plus b. Now let's have another function. Perhaps let's build the one a little bit more complex, sum2, that will sum all the numbers up to n. 0 plus 1 plus 2 plus n, anyway, up to n, right? And we'll do it in the same way we did it before. We'll have a sum here inside. We're gonna use a for loop, I less than n, I plus plus. We're gonna say sum plus equal n, and return sum. And let's build also factorial, and I think that should be enough, right? So function factorial will also take an up to n. So it's the product of natural numbers 1 times 2 times 3 up to n. So this one we're gonna basically have a variable that it's initialized with 1 because this is the neutral element for for multiplication. And let's have the same kind of structure here, similar to the sum, but basically we'll start at 1 like we said. And perhaps we should go up to n here because we want, yeah, up to n, so plus equal. And here we have to do prod star equal I and return prod. Okay, so we have three functions, and these three functions we place them inside the mathutil function. But you know what? Let's take one step back and actually let's cut these functions from here, remove mathutils altogether, and just place them on a brand new code page here. So we have three functions. Pretty simple function, nothing about closures until now. How can we use these functions, right? Let's use them here. Let's use the first one. We just use it like this. We invoke it with some numbers. Let's use the second one. Perhaps we should have sum to 10, which we know is 55. And then we should invoke also factorial, which is, I don't know what factorial of 10 is. But anyway, we'll run it. Probably it's right. Oh, this one is 110. Why is that? Sum 2. So 1 to up to 10 is 110. What's happening here? Oh, we are adding n all the time. It's plus I. Yeah, and the other one is correct. It's 55, and this one is factorial, which we can check really quickly, but that's besides the point. All right, so we have three simple functions, right? So now we're gonna see that with the help of closures, we can just put all these ones in a small compact module and will all live inside and if they need, they can also share variables between them, and these variables will not go outside, but they'll remain inside the closure. So the way we're gonna do that, we're gonna rebuild the function mathUtils, and we're gonna copy these functions, actually cut them and place them inside. All right, so now they are inside this function, but the question is, how can we use them? Because right now we'll not have access to them. If we run the program, of course, these functions are not available. They are somehow inside the mathUtils function, right? So how can we return them? Well, obviously with a return instruction. But we have more than one. If we have just one, we can just return it like before. But if we have more than one, how can we return multiple values from a function? With the help of an array or an object. So we can either place them in an array and return all of them like this. And we did that. We did that in the past when we placed functions inside an array. This works perfectly, and on the outside we'll access them. For now, let's choose them to place them in an object basically. So we're gonna replace the square bracket with curly bracket. So looking at this line, we see that we are returning an object with three properties: sum, sum2, and factorial. And basically these are the functions that we are interested ourselves into, right? So how can we use them? First of all, let's receive this object in a variable. Let's invoke mathUtil, and basically because it's returning an object, we'll receive this in a variable. So let's do this one here. And we should name this one utils or math. Let's name it math equal mathUtils, like this, right? So math at this point is not a function like it was before, but is actually an object of functions. And the first function is named add, the second is sum2, or doesn't matter the order, since we can access the object by the inner properties by name. So therefore, we can just put math dot in front of these guys here, and if we'll run it, oops, sum is not defined. So if we'll run it, oh, we are not returning sum, we are returning add here, add sum2 and factorial. If we'll run it, we should see back the numbers. Very interesting, right? This is what is called the module pattern. It's used a lot in JavaScript, and you can also make use of it if you want to basically encapsulate a series of related functions, and you don't want them to, to remain loose through the code. You can just encapsulate them in a bigger one. And as I mentioned, these functions also, they can share state or share variables between them. For instance, we can have a variable here, such as, what can we have? Let's have a delta, which is, just certain number, to say like that. And, delta can participate, or let's have it as a string. Prefix, we'll name it prefix. Result is, we'll just name it like that, right? So these functions will make them return not numbers, but actually strings, right? So what we can have, we can just return prefix.sum and so on. See? And now if we run it, we should see basically that string is here. And all these functions are actually making use of this, it looks like a global variable, but it's actually inside a variable inside the outer context. But the nice part about it is that no other piece of variable is basically going outside. So we are not polluting our programs with unwanted variables. Here we can have as many variables inside. Perhaps we can have, mathematical constants, perhaps epsilon, or we can have, since this is a mathUtil, we can have e, or we can have pi, and we can have lots of variables inside that can be used by these functions. But all these constants and all these functions remained tightly contained within the mathUtil. And then when we want to access them, we can just invoke mathUtils. We obtain the results like an object, and this basically we get access to the inner functions, and then we can just invoke them using the dot notation that we use basically until now to invoke functions within objects. Remember the lesson from yesterday. All right, so let me name this one metutils. So this is basically closures. This is closures 4. And let me put this one on the chat. And for whatever reason, I don't think I saved I put on the chat closure 3. So let me bring that one really quickly. Is the one with the printer in graphical mode. Let me put that one on the chat as well. Who knows? Somebody may want to improve it and create a really nice program out of it. Closures 3. So that was the graphical printer. And let me put now the methutil on the chat. This one. Closures 4. And again, I'm going to take just 1 second to highlight on the paper this module pattern. It looks really interesting. Again, it's nice to have knowledge about it. So let's just write it in the form we wrote it together. So we say we need a function in order to implement it. Of course, a name. We just say metutils, like this. And the main point inside that will have multiple functions. Function fn1, and we'll have a body, and the same will have fn2, and you know, as many functions as you want inside. And we're gonna return what we are returning. We'll return an object or an array, but an object is much nicer and preferred, with the functions that we want to return from within this object. And notice something here. We don't have to return all the functions. So if we have a private one or an inner function that we are not interested in returning, perhaps some partial calculation function. So perhaps inside it's a function, partial calculation, and this one it maybe is used by other functions. We don't have to return it, so we are returning only the functions that a potential user may want to use. And how we're gonna use them? Well, simply we'll say const, we'll use a variable math equal metutils. We'll invoke the function, the outer function. And in the moment the outer function is invoked, obviously this return line will happen. So at this point on the object math, we can use any of the functions inside, like this. Make sense? I hope that it makes sense. Anyway, let's do one more example. Perhaps this will better clarify this one. And what better example to do than perhaps do a small graphical example this time. Let's start a new code editor here, a new page on the code editor. And I'm not sure if you are hinting what I want to do, but I'm just thinking to redo the example that we did yesterday with the bubble. So let's have let's use basically this module pattern that is built on top of closures and build a bubble enclosure, and is bubble enclosure basically some sort of function that will contain basically all the logic to display and update a moving bubble on the screen. You know, the kind of circle that goes on the screen and bouncing on the edges, right? So that will be the bubble function. And we said this one will gonna contain all the display and update logic for that bubble. Remember that bubble, we basically need to display it or render it in some way, for perhaps using a circle command. And then we need to update the state of the bubble, basically move it around and verify if it hits the edges and so on and so forth. So therefore inside we need to have two functions, display and a function update. We'll use the same pattern that we use in the other examples that we build with this bubble, but this time the functions we play them inside the bigger function. All right. So from the outside, we basically need to obtain the bubble. We are invoking basically the outer function bubble, and we get an object. We didn't return the object, and from inside we are returning an object with display and update, right? So therefore from the outside we are obtaining this object, and on the object we can call at any time bubble display and bubble.update, just like this. But of course we're not gonna call them here, but instead we're gonna define a small function loop, and we'll have to clear the screen all the time, and then bubble display and bubble update. And notice here the invocation looks strikingly similar. Actually, it's 100% the same as the one from exercise that we did yesterday when the functions was placed in an object. Of course, this time is also placed in an object, but the whole construction of object is different. All right, so this is basically the skeleton of the program that we want to build, and now it's up to us to implement basically this logic of displaying, of updating, and so on and so forth. So let's go inside the outer function here and define a few variables. A speed that has a value of 3. We're gonna just use similar constant as yesterday. An x that it's a random of 800, a y random of 600. The idea is that x and y are the coordinates of the bubble that are moving on the screen, and then we need those dx and dy variables to specify the direction, either -1 going to the right, -1 going to the left, and the same for vertical. So let's have a dx which is a random number, either -1 or 1, and dy the same. Dx means delta x, or direction on x. Perhaps direction on x this time, not delta x, because it's always 1 or -1, but we're gonna multiply it with the speed to actually obtain the actual delta. So what we're doing for display, very simple. We're gonna just use a circle at x and y and a certain radius. Why not have also, let's have also radius as a constant here, as a variable, and radius r. So that's all. We're just doing a circle there. Pretty simple, right? And let's run it to see it in action. We have a small circle. If we run it again, probably should appear in other position. Yes, indeed, because of the random. Yes. So let's look a little bit closely at this time at the entire module here. Notice it has 2 functions inside. We are returning these ones, but it has also a series of variables that are just inside this bubble, inside this closure. These are not seen from outside. From here, we cannot access in any way the x or the dx or those variables. And this is a good thing, because we don't want to pollute the space here with those variables. Perhaps here we can have our own x that has a different value, and we don't want to know that other things overrides our x, right? So those things better remain with their proper scope here inside the bubble, inside the enclosure, inside the closure, and be used just by these 2 functions here, because only these one are interested in these variables. On the outside, nobody has interest in them, and they even provoke more trouble if they get overwritten, or they collide with other variables with the same name. All right, so let's implement quickly the same update logic that we implemented so many times for this exercise. So speed times dx and y, we increment it by speed times dy, right? And now the bubble moves. We can see it if we want to at this point, but it leaves the screen. We need to make sure it doesn't leave the screen, so we're gonna verify if x is less than 0 or x is greater than 800. We invert the dx, right? Dx multiplied by -1 to change the direction. If y is less than 0 or y greater than 600, dy, we multiply it by -1. All right. So I think we are in good shape right now. We don't have to do anything. We just have to run it. All right. And we can enjoy our bubble. And now we can transform this and having multiple bubbles and that they just go on the screen and then bounce from the edges, perhaps even bounce from each other, something like that. From now on, it's up to our imagination. But let's analyze again what we did here. And perhaps we should compare this code with the one that we implemented yesterday. So let's first save it. This one is bubble with closures, Save it. Let me place this one on the chat. All right, it's there on the chat. And let me open here also the example that we did yesterday. Yeah, if we can locate that one. So should be bubble 1 perhaps. Yeah, we can have this one. Or bubble 2. In bubble 2 yesterday we wrapped the entire object in a function, but this one is fine. So let me just move it here on the side a little bit and analyze the two examples. Let me hide myself. And let's notice this one is the one that we did yesterday. Basically, it's kind of, if you compare them, looks strikingly similar, but there is a difference. When we access the properties X, Y, and R here, because they were properties inside the object, we had to use the this dot syntax, right? Like this dot X, this dot Y, and so on, so many times. All these highlighted areas are using the this dot syntax. When we just use the closure, we don't have any of those situations. There is no this inside here. The only object that it's used inside the closure here is the one at the end, actually, and this is just for the mere purpose of actually returning the two functions. And as we said, we can return them either via an object or via an array. But nevertheless, when we are consuming them, basically we are invoking the same. So this kind of pattern with closures and this whole module pattern, it basically can be used very well for replacing some object-oriented kind of encapsulation, the one that we basically did yesterday. However, we're gonna talk more about object-oriented in a future lesson. For now, this is all that I have to to show you about closures. I recommend you to practice. More importantly, start practicing with this module pattern, and then if you are attracted by functional programming or declarative type programming, try to practice also with the other types of patterns, like a function returning a single function. And if you like closures, you know, closures are everywhere. You can use them in very interesting and constructing ways. All right, so that's all for today. Thank you for watching. Happy coding, and see you next time.